Okay, so factoring and greatest common factor, GCF stands for greatest common factor. So our objective is to take all common factors out. As I mentioned earlier in the semester, we want to write expressions in terms of factors. We always want it that way. So in the last problem, 4 was a factor. So I pull that out. So GCF is the proper way to identify a factor. Sometimes it is easy. For instance, 4 was easy to spot in the previous problem. Sometimes it's not so easy. That's when we use the process of greatest common factor to pull terms out of an expression. So let's see. We want to factor this. So when we start to factor, we are going to look at numbers and we are going to look at variables. So do we have variables in common? No. So we don't have to worry about variables. Do we have numbers in common? Yes. So 10, I could write it as 10 times 1. The next step must be to write the other number, if at all possible, in terms of the number you already have. So 18, I could write it as 10 times 8. I'm starting with this because once you understand this process, the complicated ones fall in place. So what is common to those two terms? 10. So 10 is the greatest common factor that is in common. Why do we call it the greatest common factor? Sure, I could write 80 as 16 times 5. Yes? 16 certainly is bigger than 10. Do we agree? But I can't pick 16 because that is not the greatest common factor. See the difference? Definitely this is bigger than 10, but it's not in common. So we can't use 16. Rather, we stick with 10. Good. So 10 is a common factor. So if I pull 10 out of the expression, I like to switch between parentheses and brackets. Either would work, it's entirely up to you. So if we pull 10 out, we would have 8. 10 comes out of that expression, I'd have minus 1. So it's 10 times 8 minus 1. So that is a factor, 10 is a factor, 8 minus 1 is another factor. Are we clear? So 5y squared minus 25y. We have numbers to look at. Do we have variables? We have one variable, which is y. So I'm going to start with the biggest number, which is 25. Want to see if I can rewrite it in terms of the smaller numbers. I can write 25 as 5 times 5. Next, I move on to y squared. Is it possible for me to write y squared in terms of y. Yes, so y times y. The other term is just y. Should do it here on the side. The only way to write y is y times y. Correct? For the numbers, I have 25. The other number is 5. So I could write 5 as 5 times 1. Keep in mind, 1 is a factor for every expression and every number, but it's useless in a problem like this, right? No one cares if 1's a factor because it's always there. What is common between those two numbers? 5. What is common between those two expressions? Y. You can see that I started with the bigger number and tried to write the bigger number in terms of the smaller numbers, in this case number. Started with the biggest power, y squared, and tried to write y squared in terms of the smaller powers, so y. So the greatest common factor is simply that 5 multiplied by y. So we have 5y. Good. Our objective is to take that 5y out of that expression. So 5y squared minus 25y. I am pulling out the greatest common factor. If 5 comes out of the first term, I am left with 1. If y squared, if y comes out of the first term, I will simply have y. In the second term, if I pull 5 out, I'm left with 5. If I pull the y out, I'm simply left with 1. So I can leave it that way. 5y is one factor. Y minus 5 is another factor. Good. So 2 terms, we have a number and we have a variable. I'm going to start with the bigger number and try to write it in terms of a smaller number. So 64 is 16 times 4. 16, I could write it as 16 times 1. Yes. What is common between the two numbers? We have 16 in common. You may argue, well, I could write 64 as 32 times 2, but sure, you can, but 32 is not in common. So 16 is the largest factor that you can find in common between those two terms. The variable is a squared and a. You start with the term with the highest power, which is a squared, and try to write it in terms of the other term, which is a. So I can write it as a times a. A is simply a times 1. Yes. What is in common? A. So the greatest common factor is 16 multiplied by a. And that is the factor we are going to take out of the expression. So If I put out 16a, I'll leave a behind. A comes out of 64a. I took 16 out as a factor. That would simply leave it with 4. You can always verify the answer by distributing it back in. If you want. How many terms do we have? That's an easy question. 3 terms. We have 3 numbers. And how many variables do we have? 2 variables, A and B. Should we bother about B? No, because B is not in common, so I don't care about B. I'm going to let B be. So we'll start with 32, and I'll try to write 32 in terms of the lower numbers. So 4 times 8. The next number is 8. I will try to write it in terms of the next lower number, which is 4. 4 times 2. Lastly, I have 4. But 4 is just 4 times 1. What is the common factor? 4. Moving on to A, let's start with the one with the highest degree, so A squared, and write it in terms of the low ones, which is just A. So A times A, and A, which is A times 1. What do we have in common? A. So the greatest common factor is simply 4 times A. Good. Now we can start taking the common factor out of each term in the given expression. So 4A. 4 is taken out. A comes out of A squared, so we have A. B remains untouched, so B cubed. 4 comes out of 8, so we have 2. A has been taken out. B remains untouched, so B. 4 comes out of 32, 8. A moved out, so simply 8. Good. So start with the numbers. How many variables do we have? 3 variables. One variable. And we have to worry about that variable because it appears in all terms. We have 3 numbers. So I want to start with the bigger number and split it up in terms of factors so that I can sort them here and there. So 30, I can split it up as 6 times 5 because 24 has a 6, 18 has a 6. I can write it as 6 times 4. Sure, you may say, well, 30 can be written as 15 times 2. Yeah, sure, but 15 is not common in the other 2 terms. So the next one would be 18. 6 times 2. And over here, you could write it as, 6 times 3. You may say, well, 12 is a factor, but 12 is not common to the other 2, which is why we call it the greatest common factor. So the common factor here is 6. moving on to y raised 4, we want to write y raised 4 in terms of the lowest power that you can see. What do we see? Y squared. So y squared times y squared. We want to write y cubed in terms of y squared. So y cubed would be y squared times y. Y squared in terms of y squared would simply be y squared times y. Yes. What is the common factor? Y squared. So the greatest common factor is 6y squared. Good. So that is the factor that we have to take out from each of those terms. So 6y squared. 6 comes out of 30. We will have 5. 6 times 5, 30. Y squared taken out of y raised 4 will leave us with y squared. You can always go back here and say, well, if I take out y squared from y raised 4, what am I left with? Y squared. If I take out 6 out of 24, what am I left with? 4. The second term, I took y squared out of y cubed, I'm left with y. Last term, 18, I'm taking 6 out, left with 3. There is a y squared, I'm taking all of y squared out, I'm left with 1. So 3 times 1 is simply 3. If for some reason you picked the greatest common factor as y, even though it's wrong, it is a common factor, well, it's not the greatest common factor, you'd have to repeat the process twice to get to that answer. Does that make sense? So it's like eating the sandwich this way instead of that way.